Now I'd like to talk a little bit about parachutes. When the CanSat is deployed, it needs a parachute to slow it down. Otherwise it'll crash to the ground and break into tiny little pieces. It's easy to make a simple parachute, okay? Just a piece of fabric, some strings. To design one that works really well though is a slightly more complex issue. The CanSat competition requirements may vary slightly from year to year, but generally they'll specify a maximum and minimum speed of descent, and there'll be some limitations on the volume or mass of the combined can and parachute. When it comes to the design, there are a lot of variations to consider and a lot of decisions to be made. Decisions about the type of fabric, the type of cord you use. Because remember, when the CanSat is deployed initially, it'll be quite violent, so they have to be able to take quite a bit of force. You'll also need to think about the shape, the size, whether you'll have a hole in the top or not. Most commonly available parachutes are in fact created from standard two-dimensional flat geometric figures, such as hexagons or octagons. The one in the diagram here consists of 8 equal triangles. Another type is the semi-spherical chute. Although it's not too difficult to make, it can be time-consuming to get the shape right. Instead of using a semi-spherical shaped parachute, you could choose to use a cross shape. This one is easy to make. A parapente shaped parachute acts a bit like a wing. Because of its shape, you can use it to steer. The design of a parapente is more complex than of the other shapes. You'll have to do a lot more research if you want to use this type. In order to make good parachute design decisions, let's take a closer look at the physics behind how a parachute operates. As the CanSat descends, it's subject to two opposing forces. The force of gravity acts downward. The effect of the force of the gravity is to cause the CanSat to accelerate, to cause its velocity to steadily increase. The size of the force of gravity is dictated by this formula here. Now, in the opposite direction, we have a drag force, which acts upwards. The drag force is caused by air resistance, and the size of the drag force depends on a few different factors. It depends on these three items here, CW, rho and A, and they depend on the shape and size of the parachute. The other thing that influences the size of the upward force is the velocity of the can. Now, we know that gravity is causing the can's velocity to increase all the time. So if it's increasing all the time, then the drag force is increasing all the time. So as the can falls, the drag force increases until the drag force exactly equals the force caused by gravity. And at that point, the two forces cancel each other out and there's zero net force acting on the can. This doesn't mean that the can just stops. It means it stops accelerating. So it moves at a steady velocity called the terminal velocity. The terminal velocity is the steady speed at which we hope the can will hit the ground, and that is specified for the competition to be between two values, a minimum and a maximum. So you need to design your parachute and your CanSat so that this terminal velocity is correct. So if you look at the formula here, we know that a terminal velocity, the force of gravity, exactly equals the drag force. So this formula here is true. So if we were to juggle that formula around, we get this nice formula here. And this is telling us that the area of our parachute should equal this. So the area of our parachute should equal its mass by 9.81 by 0.5 by these two values, which depend on the shape or the style of parachute you've chosen, multiplied by the velocity, the terminal velocity that you want, which should probably be, you should choose to be the midpoint between the required minimum and maximum. Having said all this, the design of a chute is quite a complicated process, and the maths on the drag force formula can only really approximate what will happen. So to really find out, you need to get out there and do some experiments. So maybe get a can, fill it with sand or something to meet the weight requirements and experiment. And you might make sure your teacher supervises that too.